See what is first, let us understand what is meant by electric field, and then we'll see what is meant by electric field intensity. See, regarding electric field, if you have a charge with you, just look in the screen. If you have this charge plus Q charge, so it will be having certain electrical environment around itself, certain environment where electrical properties can be felt. Now see, if I bring a small charge, small Q charge in the vicinity of this capital Q, so what will happen? If both the charges are positive, then both of them will repel each other. So if the charge is very far away, like in this position, in this first position, then we see that there is no repulsion felt. Why? Because of inverse square rule that we have seen. F is equal to KQ1 Q2 divided by R square. Remember Coulomb's law?
Yes, teacher.
All right. So see, if you increase the distance, what will happen? Force will automatically get reduced. So if plus capital Q and plus small q, both of these are separated far away, then nothing is felt because force will not be exerted. But see, as you bring the small charge, small q, towards this capital Q, what will happen? As you bring this charge near the vicinity of this plus Q, certain electrical properties will be felt. If it's a positive charge, if this charge is a positive charge, then you see repulsion will occur. If this is a negative charge, then you see attraction will occur. But only in a confined certain place we are able to notice these forces of repulsion or attraction. No. So the space around any charge in which electrical phenomena or electrical environment of the charge can be experienced, that we called as the electric field. So electric field is nothing. It is just basically if you have a solo charge with you, single charge with you, and the surrounding environment or the space around that charge in which electrical properties can be felt. Electrical properties can be felt means all the types of forces can be felt. Like if it's a positive charge, then repulsion will occur if both the charges are positive, and if both the charges are negative, again repulsion will occur. And if it's a case of either positive or negative charge, we can see attraction will occur. Now see, all the force, we say that this charge is stationary charge. We didn't move this charge. This plus Q was stationary. So we call this charge as a source charge. And just in order to check whether this charge is positive or negative, or whether it's exhibiting any environment around itself, we bring this small q towards itself, towards the source charge. So we call this small charge as the test charge. So now see, whatever forces are experienced by this test charge because of the source charge. See, the source charge is generating certain electrical field around its environment. Because of this environment, because of this electrical environment, this small q charge is getting forces of repulsion or attraction based on the sign. So these forces experienced by the test charge because of the source charge, that is known as electric field intensity. This is known as the electric field intensity. So if this is the test charge, this is the source charge, then all the electrical forces experienced by the test charge because of the presence of the source charge, we call it as electric field intensity. So if the test charge is a positive charge, let's say the test charge is a unit charge, means the magnitude of this charge is 1 coulomb. So what will happen? All the force that will be experienced by this charge, this will be equal to the electric force. Like if I show you, see, this is the formula of electric field. Electric field intensity, this is equal to force divided by the charge. Why? Because whatever is the force experienced by the charge, we say that is the electric field. So just whatever you have studied in Coulomb's law up till now, do one thing, just divide it by the test charge, by one of the charges that is coming closer to the vicinity of the source charge. Then you say whatever force you are getting, that is equal to the electric field. Like if I tell you, if E is equal to F divided by Q, So especially Salman and Khalid, you tell me, if I make this Q equal to 1 coulomb, then what will be the relationship between electric field and force?
Electric field will be equal to force.
Electric field will be equal to force. That's what is meant. What is the definition of electric field intensity? You can define it in this way, that electric field is the total force experienced by a unit positive charge. So is the concept clear? Then you will be able to understand.
Yes, ma'am.
Okay, so any doubt, Salman, Khalid, both of you from the previous lecture or any one of you from the last class, if you have doubts? We just started with electric field and we had seen electric field's formula for a point charge. So see, for Coulomb's law, you know what is the formula. If two charges are there and they are separated by certain distance small r, then you can easily figure out F is equal to kq divided by r square. So see, if electric force is this and electric field is force divided by charge, so what you can do, just simply cancel the test charges. So you will be left with only the single charge. So this also shows that electric field is the property of a single charge. See, force comes due to interaction. If you have two charges in line, then both of these will be exerting force on each other. That's how you get Coulomb's law, this relation. But electric field is force per unit charge, per unit positive test charge that we say. So because of this relation, you get this Q vanished. So you only have the source charge with you present. So the formula of electric field for a point charge or any spherical particle becomes 1 by 4 pi epsilon naught. This is for K, Q divided by R square. Is this clear?
Yes, teacher.
All right. See, for a positive charge, you just have to remember the direction, that electric field is always away from the charge. Like if you have a positive charge plus 2 coulomb. So if I take this point A, so away from this charge will be towards the right hand side. If I take this point B, away from this charge will be towards the left hand side. Similarly, just opposite for the negative sign. If you have minus 2 coulombs with you, if you have positive A, if you take a point A, then see, it will be towards the charge. That will be opposite to the previous case. It will be towards the charge, so it will be on the left hand side. Similarly, if you have B point, if you take this B point, then towards the charge. Whenever you see negative charge and you have a point, just take the point towards that charge. And whenever you have a positive point, a positive charge and you have a point, then just move this point away from the charge. That's how you will get the direction of electric field. And also, as we have seen for force also, for different media, we have different values. If you have 1 by 4 pi epsilon naught q by r square for vacuum, this is electric field. And if you have a separate medium, if you take a different medium, then instead of writing epsilon naught, a dielectric also comes. This also you must have missed, because dielectric constant and permittivity we have done in the previous class. So for just now, for understanding till this lecture, you just remember, whenever media is changed, whenever from one medium to another medium charges are displaced, then what happens? The electric field or the electric force, these quantities do not remain same. So what happens? Every medium has its dielectric constant value. So this gets multiplied with the permittivity of air. So whenever you have different media, you can use this 1 by 4 pi epsilon q by r square, where epsilon is the permittivity of any space, any different medium. But if you have the relation, if you have dielectric constant with you, you can use 1 by 4 pi k epsilon naught. K epsilon naught is equal to epsilon. This we have done in detail in previous class, so that's why you might have difficulty in understanding this. But if question comes, we can discuss it later on, and if you have doubts, you can ask me. But till
Ma'am,
now, yes, sir.
videos are available, right? Like last class.
Yes.
Video is available, right, of the last class?
Sorry, Salman. Can you say? You can repeat.
Recorded videos are available, right?
Yes. Recorded videos are available. So you can look in the lecture, and if you have doubts, you can ask me. This is just this is a brief part so that you are able to understand today's class. All right. So we have done this question. Okay. Now see. So electric field for others also. This topic has been revised. So I hope no doubts are left from electric field. We have a new student, Abdur Rahman. Abdur Rahman, is this your first class? All right. So we have started with electrostatics, and in electric field and charges, we have seen electric charge, Coulomb's law, and then till the last class, we had seen electric field. Now see, regarding the graphs, before we move on to the graphs of specifically this chapter, just understand graphs, you know from your lower classes that it is simply pictorial representation of a function. Representation of function. So graphs basically represent any function that you have. You should remember that if y is somehow proportional to x and x is to the power 1. So this is what kind of equation from your mathematics, and I think in 8th class you had this chapter. So this shows the linear equation. Whenever something is proportional to the other quantity with the power as 1. So what is the graph that we get whenever we have such kind of relation? If you remember, if both the quantities are directly proportional to each other. So if you increase x by some amount, then y will also get increased by some amount. Then again, if you increase x by the same amount, y will also get increased by the same amount, because both of them are directly proportional to each other. So if this is x, this is y, then both of them become directly proportional to each other. This is how a graph looks like. Secondly, this is for a linear equation. This is just a recap of your previous classes. For all those who know this, need not write it down. All right. See, if you have equation where x varies with where y varies with x, but here x is raised to the power 2. So what kind of equation is this? Again, linear equation.
No, quadratic equation.
It's a quadratic equation. This becomes a quadratic equation. So the graph varies like this. We get a parabolic graph. This is a straight line. The last kind of graph that not the last kind, but one of the graphs that is left is if you have any variation like this, when y is inversely proportional to x, or when in the previous cases y was directly proportional to x, just the difference came in the power of x. If y is inversely proportional to x square, if y is inversely proportional to x to the power 3, and so on, you take any value of x to the power n, what happens? The graph that you get is a hyperbola, which shows that both the quantities are inversely proportional to each other. If this is y, this is x, the graph will be in this manner. So see, I have to take 10 minutes break. I have to open my Rosa. So just do one thing, note this down and try to draw the graph of Coulomb's law. 2 graphs you have to draw. Force with 1 by r and force inversely proportional. Force versus radius only. Okay, I'm just coming in 10 minutes. Yes, written. Till here you must have written. Just note down this one also. And for those who have drawn the graphs, just do one thing. From your Coulomb's law, you have the relation. So just use the formula F is equal to K Q1 Q2 by R square. So from here, draw two graphs. First one, draw for F versus R, and the other one, draw for F versus 1 by R square. This F versus R square, another one F versus 1 by R square. And just let me know when you are done. So have you drawn the graphs? See, from your Coulomb's law, if you first have to draw F versus R graph for Coulomb's law. And then you have to draw F versus 1 by R, not F versus R, F by R square. And F versus 1 by R square graph for Coulomb's law. So see, the formula of Coulomb's law is this 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So this is the formula of Coulomb's law. For students who are new and who have not done this, this is the formula of Coulomb's law. Now see, the magnitude of charge will remain constant. 4 is a constant number, pi is a constant, epsilon naught is constant for each media. So this is whole term is constant, k that we say, whose value is also 9 into 10 to the power 9. Magnitudes of charges are constant. So see, what is variable? 1 by R square and forces are variable. So as you increase the distance, the force gets reduced, force gets weakened, and as the distance between the charges get reduced, then the forces become stronger. So if you increase the distance between the two charges, then the force weakens, and if the two charges are kept closer, then the force is stronger between them. So now see, regarding F versus R square, how is force varying with R square? Directly proportional to R square, inversely proportional to R square?
Inversely proportional.
Inversely proportional. So in inversely proportional, what kinds of graph do we get? We had seen three major types, 1, 2, and 3.
The third one.
The third one, this is the hyperbola. First one is the straight line graph, second one is the parabolic graph, and the third one is the hyperbolic graph. So if you have F versus R, only F versus R square. So force is since force is inversely proportional to the radius, to the distance, we can draw the graph in this manner. This is force, this is radius. Both are inversely proportional to each other, since this is the reason for that. And we get the graph as hyperbola. But see, regarding the second one, this was for the first part.
Parabola.
Which answer? Yes, Shabu?
Parabola.
Parabola, second one. Why? Any reason?
Ma'am, when the force is directly proportional to r square and the graph for y directly proportional to x square is parabola.
See, this is the formula that you have, k q1 q2 divided by r square. All right. Now see, in the first part, the question was asking you force versus the distance. So force is inversely proportional to the square of distance. So you got the graph like this, the way we have drawn it for the first part. Regarding the second part, it is asking us force versus 1 by r square. How is the force varying with 1 by r square? It is directly proportional. Force is inversely proportional to r square, but force is directly proportional to 1 by r square. No, see, from this relation, k, q1, q2, these are constant. Force is directly proportional to 1 by r square. That's why force becomes inversely proportional to r square. Is this difference getting clear when you only have r square with you and when you have 1 by r square with you? So here f is directly proportional to 1 by r square. In the previous case that we have done, force was inversely proportional to r square. When you have 1 by r square, it becomes directly proportional. Any confusion in this part? How are we saying directly proportional and inversely proportional? See, just replace any term wherever you are having confusion, just replace the term with x. All right. See, in this part, in this first part, let's replace r square with x. So the formula was k q1 q2 by r square. So force versus r square. So let us replace the term with x. So we'll see f is inversely proportional to x square. 1 by q1 q2. This is x square only. We just have to replace r square with x square, because in the first part it is saying force versus r square. So from here, rest of the terms are constant. We can directly say force is inversely proportional to x square. Fine. So that's how we have drawn the graph. Now see, regarding the second part, it is saying force versus 1 by r square. So whatever term is given to you on the opposite side of the graph, just take it as x. So here 1 by r square, take 1 by r square as x. So what you will see, f is equal to 1 by r square becomes x, k q1 by q2. If you take k q1 by q2, f is directly proportional to x, means f is directly proportional to 1 by r square. So when this is the case, if two quantities are directly proportional to each other, then what kind of graph do we get?
Parabola.
No, no, no. See, linear equation when y is directly proportional to x. We got this was a linear
Or straight
equation,
line.
straight line. Parabolic is when it is to the power 2 square. No, see here we are not getting x square. We are getting x. Had it been 1 by r to the power 4, then we would have taken x square. In this case, force is directly proportional to 1 by r square. You don't have to check whether r square is having the power 2 or 3 or any power. You just have to check what the question is asking. Question says force, one quantity is force, other quantity is 1 by r square. So you just have to check how both these quantities are related. Force is directly proportional to 1 by r square. Just to make your calculation easier or to understand easier, replace whatever term is given with x. So you cannot change the power. You cannot make it f is directly proportional to x square. You just take whatever is given in the question, like 1 by r square was given, just take it as x. So you will directly see this relation, f is directly proportional to x. So that's why we get the straight line. Why? Because f is equal to k q1 q2 by, you can write it in this manner also, 1 by r square. Are these two parts clear, or should I repeat it?
Yes, teacher, clear.
All right. So just note these down as well. Then we'll do the graph for electric field. So all those who will write it down till here, just let me know what is the nature of the graph for the second question, E versus R. You have the formula for point charge, electric field for a point charge. Answer me in the chat box. Just let me know. Is it a straight line? Is it hyperbola? Is it parabola? Yes, Atif, now it's correct. The second answer which you gave. That is right. Yes, anyone else answering? Or let's discuss.
1 and 1.
Okay, okay, okay. Okay, let's discuss it then. See, what is the formula for electric field for a point charge?
E is equal to K Q by R square.
KQ by R square. This is the formula for electric field of a point charge. K and Q are constant. So how is E varying with R?
E is directly proportional to 1 by R square.
E is directly proportional to 1 by R square. Fine. E is directly proportional to 1 by R square. But how is E proportional to R square? Distance, only R.
Inversely.
Inversely.
Ma'am,
See the
I thought for the second question.
yes, yes. See, E is, you have to check E for R only. If the question is asking you this part, the question will directly mention E versus 1 by R. 1 by R square or 1 by R anything. When question says R only, so it means you have to check the relation between E and R. But E is inversely proportional to R square. So which kind of graph is this? This is that graph 1 by X, where Y is
Hyperbola.
inversely proportional to X. So hyperbola. It will be hyperbola. So you have to remember these two graphs, both for force and electric field. You have electric field, then both of these will be inversely proportional. With any quantity that you increase R, with that much amount, the electric field will get reduced, and vice versa will occur. Just note down this graph for those who have not written, then we'll move to the next topic, superposition principle. Done? All right, let's move to the next topic, superposition principle. Now understand what is meant by superposition principle. See, if you have various quantities with you, like if you have various electric forces with you or electric field with you, then what you do? You have to take out the resultant of all the electric fields. Like if I tell you I have this charge Q1 with me, I have another charge Q2, and let's say there are n number of charges. I'm not even counting them, Q1, Q2, and let's say some Qn till Qn. N can be any number. You can put it 5, you can put it 4, you can put it any number. So n number of charges are present. So Q1, Q2 and Qn charges are present. So see, if I take this point, I have taken this point, let's say P point I have taken. Now see what we have studied for a point, for a positive charge. I am taking these charges as positive. So for positive charges, direction of electric field, is it towards the charge or is it away from the charge? For positive, away from the charge. So if this is the point, this is the line which will connect this charge and this point. So away from the charge will be in this direction. So this will be electric field 1. Electric field generated because of this charge Q1. Let's come to the next charge, Q2. So this is point P. Again, it's a positive charge. So let's say this point, this will be away from the charge. Had it been minus Q2, then it would have been in this manner, in the downwards direction. Since it is a positive charge, so this will be away from the charge. So direction of electric field will be this, away from the charge. So this is E2. Vectors, since electric field are vectors, arrow will represent the vector signs. So this is electric field E2 generated because of charge Q2. All right. Now see, we have taken n number of charges. We have various charges with us. So electric field generated by that nth charge that we have taken will also be away from the charge in this manner. This is En. Electric field generated by the nth charge that we have. Now see, how will we get the resultant of all the charges that we have, all the charges that are present? Electric field is a vector quantity, so it cannot be added directly. Means algebraically you cannot add electric fields. So what you do? You, all the laws that you have studied and all the parallelogram laws, whatever vector laws you have studied, so you have to add all these individual electric fields together using the vector laws, and this is only known as the superposition principle. For a system having n number of point charges, the net electric field at any point is given by the sum of electric field of individual charges added vectorically. If you have various electric fields with you, see, the direction of every electric field is different, and whenever we have vector quantities, we have to keep in mind the magnitude as well as the direction. So see, if you cannot add them directly, when can you add any vector quantity directly? If all these are aligned together, parallel to each other, making angle of 0 degree. But see, both of all these charges, they might be making some angle 120 degree, 60 degree, or any angle. So see, all these electric field, these will be given by, see, this is generating this electric field, this is generating for Q2, and this we have taken for Qn. So all the direction of electric fields are different. So how do you get the net electric field? You have to add them vectorically. By vectorically, you have to consider all the parallelograms law and all the vector law that you have studied in your 11th standard. So I'll write down for a system having n interacting point charges. By n, it means that you can take any number from 0 to infinite. N can be any number. N interacting point charges. So if you have n interacting point charges, the net electric field at a particular point, like in this case, we have taken this point P. So at a point is the vector sum. Why? Because electric field is a vector quantity. Also, had it been electric forces, forces that you have studied in Coulomb's law, and all the electric force kq1 q2 by r square. So there we had seen only 2 charges. Had there been more number of charges, more than 2 charges, then Similarly, you would have taken the direction of the charges and then you would have added them vectorically. So net electric field or any vector quantity at a point is given by the vector sum of fields due to individual charges. So net electric field, whatever the resultant electric field will be, E1 plus E2 plus added till En, but all these are added vectorically. So if like you have two electric fields with you, and they are making an angle of 90°, then you cannot add them like E1 plus E2. If you remember from your parallelogram law, whenever two vectors make an angle of 90°, you add them like this. So you have to go through this procedure and not through this one. All right. So is the superposition principle clear?
Yes, teacher.
Yes.
All right. Okay, one more thing before you start noting it down. We have a point known as a neutral point. Many of you must be aware of this point. We have a point known as neutral point. So see, neutral point is that point in which electric field of all the individual charges cancels each other. Like if I say I have a point like this, E electric field generated at this point is E, electric field generated, let's say because of some other charges, E over here. So what happens? Since magnitudes are same, E is the magnitude of this and E is the magnitude of this as well. So what will happen? Since both of them are in different directions, both of them are making angle of 180°, both of these electric fields will cancel each other. So this point that we are getting where the electric fields are cancelling each other, that point is known as the neutral point. So neutral point, you can take it for force also, where the net force is 0. And you can take it for electric field as well, where net electric field is 0. So this is neutral point is a point at which electric field of individual charges cancel each other. Cancels each other. So it's just a point where net electric field is 0. Wherever you get confused, where is the neutral point, just say wherever net electric field is 0, that becomes your neutral point. So just write down the superposition principle. We'll do questions on it where number of electric fields are given, more than a single electric field is given. Just note it down. That will make you more clear.
Mom, please scroll down. Thank you.
Have you written this theory part above the question? All of you?
Yes, teacher.
All right. So let's discuss this question directly. See, what does it say? It says that two charges plus E. Let's say we have taken a point A where this charge plus E is kept, and we have another charge. Let's say at this point B, this is plus 4E. This is kept. All right. It says that at what point on the line joining the two, net field is 0. We have to find a point where net field is 0. So as I have just told you, according to you, what point is it asking when net field is 0?
Neutral point.
Neutral point. It is asking us about the neutral point. So it can be given to you directly to calculate the neutral point, or it can give you in theory way, like at what point net electric field is 0. So we have to find out the neutral point. All right. Now see, we have to find a point where net electric field is 0. So we don't know which point is it. Is it on the line joining the center? All right. So how will we solve it? First, just understand neutral point always lies to the charge that is smaller, that is having the magnitude, lesser magnitude. So out of A and B, which do you think point is that where neutral point should lie close to? A or B?
A.
A point, because yes, definitely A point. So let's say neutral point is somewhere over here. We are not aware of. We don't know which distance is this. We are only aware of one distance that is provided to us, which is this distance. This is A. We don't know which distance is this. So we can do one thing, is that just to calculate this point, what is the separation of neutral point from this A point? Let's take this point as X. If this is X, that whole AB is small a, then what is NB? What is this distance?
X minus 6 or A minus 6.
A minus X. A, then you delete this X, you're left with A minus X. So this is A minus X. All right. Now we are calculating electric field at this point. We have assumed a point that is the neutral point. So since we know this is our neutral point, so net electric field will be 0 at this point. Now, which distance is this? What is the value of this X? We are not aware of, and we will calculate. We'll be able to calculate because we know the formula of electric field for a point charge. So we don't require the question now. This much is fine. All right. So see, if EA is the electric field generated at this point because of A point, and EB is the electric field generated at this point N because of B. B means plus 4E. This whole, the sum of both of these are 0. Why? Because net field is 0 at neutral point. That's why we have directly written EA plus EB is equal to 0. Is this much clear?
Yes, teacher.
All right. Now see, we have EA with us, we have EB with us. So EA minus EB will be equal to 0. Why? See how. Just look at this. If this is the neutral point, all right. So this is the neutral point. Because of plus 4E, electric field will be away from the charge. So because of plus 4E means because of point B, should it be towards the left or the right? Electric field generated because of plus 4E charge. Should it be towards the left or towards the right? Yes, Salman?
What's the
Left.
Left. It will be away from the charge. It will be in this direction. This will be EB. Now see, because of plus e, this small e plus e, it will be towards the right or left?
Right.
It will be towards the right. So see, since both of them are in opposite direction and making an angle of 180°, that's why I have written their magnitudes as AA minus EB is equal to 0. So if EA minus EB is equal to 0, we can say EA is equal to EB. Till here, any doubts? All right. Now we just have to put in the values of EA and EB. See, regarding EA. Regarding EA, EA is what? This is 1 by 4 pi epsilon naught charge. Charge generated due to A point is E. We can write E divided by, what is the distance that I should take for plus E?
X.
X,
X.
right? Yes, both of you are correct. It will be X. So since the formula is KQ by R square, we have to write it as X square. This is, I have written it for EA. Coming to EB, K will be 1 by 4 pi epsilon naught. What should be the charge?
Plus 4e.
Plus 4e. This will be plus 4e. And the distance?
A minus x the whole square.
Yes, correct. It will be A minus X whole square. So see, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught will get cancelled. E will cancel this E. Now see, what are we only left with? Now this is simple mathematics. Till here your physics was required. This is 1 by x square equals to 4 by A minus X whole square. So if you take square root from both the sides, it will be 1 by X equals to 2 divided by A minus X. So let's do some simple cross multiplications. This will be A minus X equals to 2x. A will be equal to 3x. Now do we have the value of x with us? A by 3. So we now know that neutral point is situated at x equals to A by 3 from point A. So this becomes A by 3 and this part becomes 2A by 3. So if the question asks you to calculate from 4e, then you can simply subtract A minus X and write 2A by 3. And if the question specifies you to calculate it from charge plus E, then you have got the answer A by 3. Is this clear? You can solve this question similar for electric force as well. Just that instead of this neutral point, you will be having a charge so that you can make Q1, Q2. All right, so just note down the solution of this question, and if you have any doubts, you can ask me also and write it in the chat box as well.
Ma'am, can you show the last part again? Last part of the whole calculation.
Last part,
Yeah. What did you
this
do
one,
there?
this
Yeah. Okay.
calculation.
Yeah.
Okay,
Okay.
see,
Okay, ma'am. Okay.
okay. All right, just note it down. So all of you have written the first part, the part above it.
Yes.
All right, Shavya, you can leave. See, for certain symmetrical surfaces, you can remember the values. Like electric field at the center of symmetrical system. This is 0. Don't write it as a question, just make it a note point. So electric field at the center of symmetrical system is 0. By symmetrical system, let's start with basic straight line. So for a straight line, if we have two similar charges, plus q, both are separated by a certain distance. Let's say this distance from a neutral point is a, this distance from neutral point is a. So this becomes a symmetrical system. The right hand side is equal to the left hand side. In the previous question that we have done, there E was there and plus 4E was there. It wasn't a symmetrical system. So that's why we knew that the neutral point won't lie in the center. But electric field for a symmetrical system is 0. It means neutral point, this is equal to, this is at the center, midpoint. So this was a straight line. If you increase number of lines, let's say if you take a symmetrical triangle system. So here at the neutral point, in this case, electric field will be equal to 0. In this figure, this is plus q, this is plus q, this is plus q. These are 3 points lying on a triangle. The separation between all these 3 are a. All right. So see, both of these, all these 3 charges are separated by a certain distance, that is a. So electric field at the center of the system, this makes it a symmetrical system. If any quantity is changed, like if you have charges value different, instead of q you have 2q, 3q, or the separation is different, this has to be an equilateral triangle, which makes it a symmetrical system. Then net electric field over the center is 0. Here then, if you increase number of lines, another symmetrical system possible is a square with all the charges equal, square with all the charges magnitude equal. So at the center, electric field will be neutral, this will be 0. Or if you have, you can keep on increasing number of lines, instead of a square you can take a pentagon. So this, if it has all the magnitude of the charges same, plus q, then at the center net electric field will be 0. So ultimately, if you keep on increasing a line, you will conclude it for a circle. So for a circle, if there are numerous charges placed at the circumference, so you can directly say net electric field at the center is 0. All right, so just note it down as well. Just try this question as well. It says calculate electric field at the center. Oh, this is a square with sides A. So this, since this is a square, all the sides will be A. Here at this point, the charge is plus Q. Here the charge is plus 2Q. Here the charge is minus 2Q, and here the charge is minus Q. So this is not a symmetrical system, and the magnitudes are also not same. So you have to calculate the electric field at the center point, that is O. So see, just the hint that I can give you is that do one thing. Firstly, take out the direction of all the electric field at this point because of all the four charges. Then calculate the magnitude of each of them and then use superposition principle, means simply add them vectorically. So you have this separation with you. You need this separation. Just try it once, and if anyone gets the answer, type me in the chat box. And firstly, tell me what is this distance coming. Just mark these point as A, mark this point as B, this C, this D. So tell me what is this coming, these separations. Just first calculate what is this separation. OA, OB, OC, all these are equal to what? Yes, this separation didn't come. See, this is a right angle triangle. You can find out this. You can find out the hypotenuse of this triangle and then divide it by 2. So as to get this length. Take 2 more minutes, at least get this value, what OA is equal to. Make this as a right angle triangle, calculate the hypotenuse, divide it by half to get this. Khalid, just check once again. Is it A root 2 or A by root 2? Yes, Salman is right. Atif is also right. See, AO, whenever we have to calculate this, AO will simply be half of AC. Regarding AC, if this is a right angle triangle and you apply Pythagoras theorem, you have A square plus A square under root by 2. So this becomes root 2A square divided by 2. This will be till here. A root 2 divided by 2. Yes, yes. A root 2 divided by 2 is A by root 2 only. This becomes A root 2 divided by 2, which you can write as A by root 2. So OA, OB, OC, all these are equal to A by root 2. At least find out the direction at point A for Q, for plus 2Q, for minus 2Q, for minus Q. Make down the, write down all the directions. All right, see, for A point plus Q, the direction will be away. So at point O, for this plus Q charge, away means in this direction. This is EA. Then we have plus 2Q. For plus 2Q, the charge will be towards where? Yes, Josefa, you tell me. For B point plus 2Q, what should be the direction of electric field? Towards plus 2Q, along OD, along OB, which direction? Yes, Josefa? This won't be towards B. See, it will be towards OD. For positive charges, we have charges away from direction of electric field, away from the charge. So if this is your point, away from the charge won't be in this direction. Towards B will lead you towards the charge. Towards D will lead you away from the charge. So this will be EB. EB for plus 2Q. Now see, for minus 2Q, you have this point. So towards the charge will lead you towards C. Means this will be EC, towards the charge. Similarly for ED this will be towards the charge minus Q. This becomes ED. Is this clear? Direction is fine.
Yes, teacher.
All right. Now see, let us first calculate the magnitude of all the charges that we have. Let's take it for EA, EC. Now we have two directions. We have this with us, OD with us, we have OC with us. So we cannot directly calculate OD and OC directly. First, we have to find out what is the resultant of this. Then we have to see what is the resultant of this. This means EB plus ED. This will, EB plus ED will give you whatever is the resultant. Then EA plus EC. EA plus EC. This will give you what is the resultant between them. And see what is the angle of the bisector at the of the diagonals of a square. Yes, what is this angle?
90.
90.
90 degree. Yes, yes, 90 degree. This is 90 degree. So we know that both of these are making an angle of 90 degree. Now we'll be able to calculate the resultant. But first we have to find out what is this EB plus ED and what is EA plus EC. Now see, regarding EA, and first let us solve this one. EB. So EB is what? B is plus 2q, no? So this becomes K 2q divided by A square. Now see, distance separation of this is A by root 2. So now you have to square this, A by root 2's whole square. So this becomes A by root 2 whole square. This is what is the magnitude of EB. So this can be written as 4 2 square 2 root 2 square will be 2. When it will be when it will go in the numerator, it will become 4. So it will be 4 k cube by A square. Fine. See, A by root 2 whole square. This is A square divided by 2. So this 2 will multiply by this, will get multiplied by this 2, and it will become 4k cube by A square. This is EB. Regarding ED, this point. Yes, Memona, you tell me. What should be the magnitude of ED? Which charge should I take? K minus Q. It will be K minus Q. Now see, since we are calculating the magnitude, direction we have already taken. So you don't need to take this minus sign. So this will be K Q for ED divided by A by root 2 whole square. So this becomes 2KQ by A square. So EB plus ED, we have this arm solved now. EB plus ED, this will be what? This will be 4KQ by A square plus 2KQ by A square, which makes it 6KQ by A square. So this we know now. Let's say this is vector first. So E1 is what? 6KQ by A square. So is this OD arm clear to you, all of you? Or should I repeat?
By the way, we won't like consider negative sign, right? In
No, we are
magnitude.
taking the magnitude. So there's no need of negative sign. If you, even if you put it, whenever you are using your vector laws, what happens? Whenever you're using your vector laws, you separately calculate the magnitude and you separately calculate out the direction. So for the direction we are using, we are constantly putting efforts on the direction as well. For the magnitude, you are using your simple parallelogram law. Fine. Yes, Khalid, is it clear?
Yes, teacher.
All right. So this solves this arm.
Yes, teacher.
All right. Now see, we have this OC left with us. For OC, we have to find out what is EA. We have to find out what is EC. So see, EA. Yes, Abdur Rahman, you tell me. What should be the charge that I should take for EA? You can type it as well. For this EA, which charge should I take? Plus 2Q, plus Q, minus Q, plus Q, right? So we have to take the charge plus Q. So see, for EA, this will be KQ divided by A by root 2 whole square. So this will be equal to 2KQ divided by A square. This is EA, 2KQ divided by A square. Now see, we require EC is left. So yes, Atif, you tell me, which charge should I take for EC?
minus 2q.
Minus 2q. So we can use the magnitude directly and we can write it as 2q only. So EC will be equal to KQ 2q, not q. K2q divided by A by root 2's whole square. So this becomes 4. Again, this will be 2 by 2 multiplied by 2, 4 KQ divided by A square. Now again for this arm that you have, for this arm, what you have to understand, for let's say this is some E2. So E2 will be what? E2 will be EA plus EC. So EA plus EC. For EA we have calculated, EC we already have. So EA plus EC will be equal to 2KQ by A square plus 4KQ by A square. This makes it 6KQ by A square again. So this solves the arm of which is present on the right hand side. This is also 6KQ by A square and this is also 6KQ by A square. Is it clear till here?
Yes.
Yes, teacher.
All right.
Yes,
Now
ma'am.
we have to find out the resultant now. We have E1 with us, we have E2 with us. We have what is the net electric field in this arm? We have the net electric field in this arm. Now we know the angle between these two, 90 degree. So apply our simple parallelogram law. So net field at the center, this will be given by EAC plus EBD, whatever we have calculated. Now see, if you apply your parallelograms law, this will be EAC's whole square plus EBD's whole square plus 2EAC EBD cos. What is the angle that I should put?
90.
90 degree. This
90
will
degree.
be, yes, it will be 90 degree. And cos 90 is
0.
0. So this will be, E will directly be under root EAC whole square plus EBD whole square. If you remember your parallelograms law, you must have done it in this way: P square plus Q square plus 2PQ cos theta. Similarly, what I have written over this side. Now see, we have the values of EA and also we have seen magnitude of EAC and EB were equal. No, both of them were coming as 6KQ by A square. So we can directly write EAC. See, EAC's magnitude is equal to EBD. So you can replace one of them, EA square plus, instead of EBD, EBD is equal to EAC. So you can write EAC whole square again. This makes it 2EAC whole square with an under root sign. This is EAC under root. So EAC square under root, this makes it EAC root 2. Is this clear till here? EAC under till here, EAC root 2.
Yes, teacher.
Okay, and what is the magnitude of EAC that we have calculated? E at the center, this is 6KQ by A square root 2. So ultimately your net electric field at the center becomes 6KQ root 2 divided by A square. Just note down the solution. Wherever you get stuck, ask me. Till here you have written till A by root 2.
Done, teacher.
Done?
Yes, teacher.